Okay, scholars, hi. We're back for the second part of 4.2 notes. And as I promised, I said I'd start with this one yesterday. Now you'll notice that this is a binomial that we're going to expand 4 times because x minus 3 to the fourth, of course, as you know, means x minus 3 times x minus 3 times x minus 3 times x minus 3. Okay, so while it's annoying, I'm going to show you a pattern that we're going to end up with. And if you can recognize the pattern from where we start, it'll save you some time. You can always do it this way. We're going to do the first example long, and then we'll see if we can figure out how to use that pattern the best way. But you know how to multiply 2 of these. So what we're going to do is we will multiply these 2, get a trinomial. We'll multiply this one, get the same trinomial, and then we will multiply everything out. So as you recall, when you multiply 2 binomials, it's going to be the first 2, the outsides, the insides, and the last 2. We'll do the same thing here. First 2, outsides, insides, and last 2. And then that way, you'll see how this works as an expansion. So as you know, x times x is x squared. X times minus 3x minus 3x. X times minus 3. Okay, then minus 3x in the middle. And then minus 3 times minus 3 is plus 9. So that's the first 2 binomials. The next ones are, of course, going to be exactly the same. So we're going to combine these in the middle because we can. Save ourselves one little step here. And now, as I mentioned, multiplication is just distribution. So you're multiplying everything times everything. So when you multiply 3 things times 3 things, you'll end up with 9 different things to multiply. Okay. Now, each time you multiply this, you'll get a new term, and then some of those terms will combine together, and we'll end up with only 5 terms. But instead of drawing 9 lines, I'm going to try to do it a little differently and see if this helps any of you in our little patterns. So I'm just going to use my finger and point, and then I'm going to draw all 9 of these out together. I'm going to start with x times this, and then, sorry, x squared times this, then x squared times this, then x squared times this. The next 3 will be minus 6x times all those 3 things, and then the 9 times those 3 things. So that's how we're distributing. So x squared times x squared is going to give me an x to the fourth. X squared times minus 6x will give me a minus 6x to the third, and then x squared times 9 will give me 9x. Now I'm going to just move my finger over here and start with the minus 6x. Now I'm also going to draw it a little differently than I normally do. Instead of all big one line, I'm going to do minus 6x times x squared, and I'm going to put it here because that gives me a minus 6x cubed. Minus 6 times minus 6x is going to be plus 36x squared. I forgot an x squared there, whoops. And then minus 6 times a positive 9 is minus 54x. Then I'm going to move over to the 9. Okay, so 9x squared. And now I'm going to put it down here so that, as you can see, they're sort of all going to line up this way. You don't have to, but it's a new way. Okay, 9 times negative 6 will give me minus 54x here as well. And then 9 times 9 gives me a plus 81. So if you like this method a little better to keep things in order, you'll see that now I have all of my variables, all my x's and the exponents that match are all in a line. So this simply becomes x to the fourth. These two I'm going to combine together because then now there's 12 of those cubes. These I end up with 18 and 36. So 18 and 36, so 45. How many does that end up being? Well, 54. x squareds, and then I have minus 108x and plus, whew, that's my final answer. I end up with 50. Now, a little bit of a pain, you may notice. Well, yes, it is. Now, we are going to talk about some special patterns because there's actually, if you recognize this pattern, when you expand binomials, you may have heard of a guy named Blaise Pascal. He came up with this triangle where he figured out how to go straight from here to here. I'd love to show it to you. First, we're going to do some other special patterns because they're in your journal. We'll just say, if you can recognize these, we'll talk about Pascal's triangle in a minute. These may save you some time. So we've talked about some of these in the past, Algebra 1 for sure, and I know in 0 chapter we talked about them. If you notice, okay, that you have two things in binomials and they're exactly the same, a plus b and a minus b. So it might be like x plus 5 and x minus 5, something like that. Or here, x plus 3 and x minus 3. Then they're going to come together in the exact same way every single time. The pattern will always be the first term squared minus the second term squared. So if a is x here, then your pattern, a squared, will be x squared. If b is 3, then b squared is 9. So this will be your final answer every time, x squared minus 9. If you recognize the pattern, you can go straight to that answer, no work in between. If you take just a regular binomial, any old binomial like what we just did, and you square it, it's always going to be the first term squared in the front, the last term squared in the back, and then these two in the middle will always combine, just like when we did that minus 3x with another minus 3x. So if it's a plus, it'll be plus twice that. If it's a minus, it'll be minus twice that. So if you have y plus 4 squared, just that binomial squared, the first term is y squared because it's y times y. The last term is 4 times 4. And in the middle, it's going to be 2 times 4. So that's 2 times 4 times y. Of course, that gives you the 8y. If your first term is 2t, then squaring that will give you 2t times 2t, or 4t squared. The last term will be negative 5 times negative 5. That's 25. And in the middle, it's 2 times 2t times negative 5. So that's 4t times negative 5. That gives you minus 20t. And that's how you can use this pattern. Also, cube of a binomial. It can be kind of a pain, but look at it. It ends up being this same pattern each time. So you can go straight from here to here instead of multiplying it all out. Now we're going to do some examples next. Because again, I was going to show you how to do those. So yesterday's notes looked like this. We did these two because they were different. That's a 3 times a 2 and a 3 of them. But if you have the same thing, see how these fit that pattern? This is cubed, this is squared, this is cubed. So I thought I would show you this pattern instead and see if we can get those done following from your student journal. So I'm going to go ahead and try to follow this pattern from these. Okay. I'm going to try to put these together in the same. So I think I'm going to fold my paper here because I want you to see how this pattern works. It's pretty nifty, actually. So as you know, you can always multiply out. Okay, here's our example. You can always multiply out x plus 2 times x plus 2 times x plus 2, but it really does get to be a lot of work. But if we recognize this pattern, a plus b cubed, it's going to follow this. So here, a is x. That's our a. And b is 2. And I'm going to follow this pattern right here. So a cubed is x cubed plus 3 times a squared is x squared times b is 2. See, I'm just following this pattern. Okay, plus 3 times a, and a here is x. B squared is going to be 2 times 2. So that'll be a 4, and then plus b cubed. So I'm just going to write out 2 to the third so I can get that written. So if I just follow the pattern, I have basically 2 steps instead of like 6. So I've got x cubed here. This is 6 because it's 3 times 2, so plus 6x squared. Plus, this is going to be 3x times 4, so that'll be 12x, and then 2 times 2 times 2 is 8. So you can add those notes to your examples. It's just a pattern. Again, you could multiply it out. Wanted to have you see this. So second example, number 6. So A is this whole thing called 4y. B is 3. But now we're only squaring it. So see how it's 2? So now we're going to use this pattern up here. So I'm going to scoot it up. Number 6 is using the first pattern right here, a plus b. So we're going to do a squared. And I'm just going to write it out. Here's a. It's going to be a squared plus 2 times a is 4y and b is 3 plus b squared is going to be 3 squared. So if I just identify and plug it in, I'm going to get 4y times 4y, that's 16y squared, plus 2 times 4 times 3 is going to be 24y, and then 3 times 3 is 9. Again, if you multiplied those two out, that's what you would get. But if you follow the pattern, it's basically one step. We're going to go back to last one, number 8, before I move on to Pascal's triangle. Number 8 here follows the plus pattern again. So see if you can follow along with it. Here's the cube of a binomial. A here is going to be 2y. B here is going to be 4. So we're going to try to follow this pattern right here and write it out. Oh, I forgot an equal sign right there. Okay. So a cubed will be 2y cubed plus 3 times a squared times b, so that's times 4, plus 3 times a, which is 2y, times b squared, which will be 4 squared, and then plus b cubed. So it's going to be 4 cubed. I should have started that over a little bit more. Okay. So now I can evaluate each part here. 2y times 2y times 2y is 8y cubed plus 2y times 2y is 4y squared times 12. So that's going to be 48y squared plus 4 squared is 16 times 3 is 48. 48 times 2 is 96, and that's a single y. And 4 times 4 times 4 is 64. So you'll notice it ends up in order. y cubed, y squared, y to the 1, y to the 0. And so following the pattern, that's what we get. And those are special patterns that you may recognize, okay, throughout this process. Now my video has come to 15 minutes, so I'm just going to go ahead and stop this one right now, because I think that's definitely enough to get you going on this. You should be able to complete all the student journal pages, and we will make sure we correct stuff tomorrow.